All right. Now, we're going to do, is that working? Is it on? We're going to do Brownstedt-Lowry, and you just put it right here on my computer. Okay, that's fine. Boom, good. Now, let's briefly look at Brownstedt-Lowry. Who's doing Brownstedt-Lowry? Yes.
Yeah.
Yes, what do you got for Brownstedt-Lowry?
Well, according to the Brownstedt-Lowry theory, an acid is a hydrogen ion donor and a base is a hydrogen ion acceptor.
All right, so an acid donates a proton. Is that what it says? So what's the most famous proton that's actually some kind of element? What's a single proton called? What is it?
Hydrogen?
Hydrogen, yeah. So if I have HCl, that's going to become H plus Cl minus. So now I have an H ion or a proton that can be donated. For instance, if I donate it to water, you see, it's going to search for a place. It needs electrons, essentially, doesn't it? Yes, it's attracted to electrons. And what are the best electrons, the easiest electrons to seek out? Unbonded ones, correct? And if I look at water, which looks like this, I have two here, so I can literally put the H plus there, correct, can't I? So now it loses its charge, doesn't it? Because it doesn't have any electrons, so it's going to take both of those electrons, and you're going to form a bond, aren't you? Yes? So that's what ion, and that's going to be an ion. You're going to ionize water, and what's that ion called? Hydronium. Is that on there? Can you see that on there?
Yeah.
Hydronium, hydronium ion. And it's going to have a charge of +1. So you're kind of donating an electron, aren't you? Yes? Now, what about the other half of it? What's a base? What's a base? What is a base?
A base is the one that accepts the ion.
What is it?
It accepts the ion.
A base accepts the ion, for instance. I have OH, correct? I have OH. And what does that mean? That means I have three pairs of unbonded electrons, don't I? Correct? And that's going to accept a plus, isn't it? Yes? And then that makes it water. So a base is a proton acceptor. I'm accepting a proton. Yes? When you're donating a proton, you're an acid. When you're accepting one, you're a base. Correct? That's Brownstedt-Lowry. Anything else about Brownstedt-Lowry? That's a big part of it. What else? Yeah, now listen carefully. So Arrhenius said that an acid is anything that dissociates into something that has free hydrogen. So anything that dissociates where you have hydrogen available, an ion, hydrogen ion. A base is anything that has hydroxide as the ion. So when we think of acid-base chemistry, when we study acid-base chemistry for the first time, and that's when we do nomenclature, right? When we do nomenclature, we write an acid like that, or like that. So when we do it, we think of that being H plus Cl minus, correct?
Yeah.
We study that in equation writing, don't we? In equation writing, nomenclature, yes? We think of a base as, for instance, I go over this in another film. Magnesium oxide, which is a base anhydride, right? It's a base anhydride. And we say, this is our language, we say, when you combine that with water, you form a base, don't we?
Yeah.
Don't we say that? Yes? You form a base. And that base is magnesium hydroxide. So when we first study chemistry, we really are studying the Arrhenius model, where an acid is H plus and a base is OH negative. Correct? Now we take it one step further with Brownstedt-Lowry. We say that Brownstedt-Lowry is an acid is a proton donor, which is consistent with Arrhenius, isn't it? Is there a conflict there?
No.
No, absolutely not. And we say a base is a proton acceptor. Is there a conflict there?
No.
Absolutely not. Correct? Now, what about Lewis? What about Lewis?
A Lewis acid is the substance that can accept a pair of electrons, and a Lewis base donates a pair of electrons.
Okay, so an acid is what? Acid. What did you say it was, Sarah?
It accepts a pair of electrons.
Acceptor of electrons. And what's a base?
It donates a pair of electrons.
Donates. Now, based on our discussion so far, does that make any sense to you? Does that make sense to you that an acid is a electron what? Acceptor. It's an electron acceptor. Give me an example, not necessarily from the book, but from what I just did. It's the same thing really as Brownstedt-Lowry, but instead of the star being the proton, the star is being the electrons. The star.
Anion and cation.
Excuse me?
Is it the same as cation and
Cation and anions, absolutely. The cation is H plus or H3O plus, hydronium, however you want to look at it. And the anion would be Cl minus 1 or whatever the case may be.
So it's saying all anions are acids and all cations are bases.
Cations are acids. The cation is what causes the acid. But let's not say that yet. That's a little bit, because you can have, sodium could be a cation. So H plus is a cation. That's an acid. OH is an anion. That's a base. But not all cations are indicative of acids. Okay?
Anions are acceptors of electrons.
Yes, but you see, you don't, that's a good point. That's a good point. So all cations are acceptors of electrons. Okay, good.
All anions.
Excuse me?
Anions.
No, an anion, is an anion accepting electrons, or the anion already has the electron, and it's kind of like donating, it's saying, come on, I want to donate electrons to you, come and join me. Isn't that what a donor does? What's an acid? An acid accepts electrons. So let's look at that. So I have H plus, right? I have H plus. Where's it going to go? It's going to go, let's look at the OH. It's donating 2 of its electrons, saying, okay, come on over here and we'll play. So it's donating electrons to that hydrogen. It's giving them away, isn't it? Yes? Isn't it giving them away? Yes?
Yeah.
So it's donating them. Isn't the hydrogen accepting them? So the hydrogen is accepting that gift. Right? The hydrogen is saying, okay, I'll take those electrons. Now, The only problem is you have to hang out with me. Oh, all right, if I knew that, I might not have done that. Okay, I don't want to hang out with Pablo. No way. Okay, so the OH, look at it from the point of view of the OH. From the point of view of the OH, the OH is donating a pair of electrons. From the point of view of the H is accepting, saying, yes, I'll take those electrons for my own. They're mine now. Mine. Okay? Easy? All right, what else did I give you? That's pretty cool. That's good. Now, somebody said to me, aren't all cations acceptors? Right? Well, yeah, I suppose sodium is going to accept, right? Right. So what? So the Lewis theory doesn't work? Well, all three theories can be used depending upon the situation. That's why we have three of them. If every situation is going to use a different theory. That's all. Do all theories work? Sure. Do all theories work in the exact same set of situations? No, you have to pick and choose what situation you're in. So you're going to apply the theories as you need them. It's kind of like the best of both worlds. Here's a bag full of theories, and no one theory is going to work, but all three will satisfy every situation. Easy? I mean, how much easier can it be? Correct? You just have to be able to explain that. Okay, now. Yes, you have a question? Okay, now. I talked some about pH, POH, what the significance of 14 was relative to pH and POH. I want to just briefly look at right now just the idea of Ka. What is Ka? What is it? Matthew? Sorry, not Matthew, Matt. What is Ka? You were in Negro. You were taking the makeup test, right? So who was the Ka group? Joseph? No, you were taking the test. Professor Connor, weren't you in the Ka? You and Dylan? Okay, so you want to raise your hand higher? I can't see. You're being very shy. You're sleeping? Excellent. You're sleeping with your eyes open. Excellent. Dylan's behaving like a horse. She's sleeping with her eyes open. I didn't call you a horse. Are you offended? Did I offend you? My apologies. I didn't mean to say you look like a horse. You are a horse.
I think we should just stop.
I think I should just stop before I bury myself too much. Understood. Very good. I apologize for any misunderstanding. Anyway, so what do we have? What is Ka? Dylan, what do you got?
Acid dissociation constant.
It's an acid dissociation constant. Write that down. Enzo, it's called an acid dissociation constant. Acid dissociation